This is Euclid Book 10, proposition number 39, and if you can see, this is the diagram right here. Alright, so what does it say? It says, if two straight lines incommensurable and square, which make the sum of the squares on them rational, but the rectangle contained by them medial, be added together, the whole straight line is irrational, and let it be called major. Now, we defined something else a couple of videos ago. Now we're going to define major. Okay. For let two straight lines AB, BC be incommensurable and square and fulfilling the given conditions, which is by Euclid Book 10, proposition number 33, be added together. I say that AC is irrational. So now we're going to start with this. We're now saying that based on Euclid Book 10, proposition number 33, this whole line is irrational. Okay. For since the rectangle ABBC is medial, so what you're going to do is you're going to draw a rectangle. Two sides of that rectangle are going to be the size of AB. The other two sides are going to be the size of BC. So you got a rectangle. Two sides are this, two sides are that. Okay. And when you draw that rectangle, automatically it's going to be medial. And if you multiply the area of the rectangle by the number 2, okay, so now you're going to have twice that size, it's also going to be medial. And this is by Euclid Book 10, proposition number 20. This is by Euclid Book 10, proposition 6, and Euclid Book 10, proposition 23, porism. But the sum of the squares on AB, BC is rational. Okay, so now you're going to draw two squares. You're going to draw a square, and all four sides of that square are going to measure this length right here. Then you're going to draw another square, and all four sides of that square are going to be this length right here. Okay, let's go on. Therefore, twice the rectangle ABBC is incommensurable with the sum of the squares on ABBC. So you remember that rectangle we drew at the beginning of the proof? You know, the two sides were AB and the other two sides were BC. If we multiply that area by 2, okay, it's going to be incommensurable with the sum of the squares that we just drew a few seconds ago. Remember, we had a square and it was all four sides was AB, and then we had another square and all four sides was BC. Well, the area in those two squares added together is going to be incommensurable with twice the area of that rectangle. Okay. And you can check this all out for yourself. So that the squares on AB and BC together with twice the rectangle ABBC, okay, that is the square on AC. So what they're saying here is when you have that rectangle we drew at the beginning of the proof, if you multiply its area by 2, then what you're going to have is the same area that you would have if you took line AC and made a square out of it. So at this point, here's what I want you to do. I want you to take line AC. I want you to draw a square out of it. Okay? And all four sides of that square are going to be the length of AC. That's what they're talking about. So twice the area of that rectangle is going to be the same area as what you'll find in that square. Okay. So, so let me list this step by step. What you're going to do is you're going to add the square on AB to the square on BC. Then you're going to add those two areas together to the square on AC, and when you add all three of those together, that whole area is going to be incommensurable with the squares on AB and BC. So the area of 3 squares is going to be incommensurable with the area of 2 squares. And that's by Euclid Book 10, proposition number 16. Therefore, the square on AC is irrational. So that AC is irrational. And because of all that, AC, the length of AC, is going to be called a major. Okay? So doing all those little computations, after you do them all, AC is irrational. And it's also called a major. And all this is because of Euclid Book 10, definition number 4. Alright. And that is the end of that proof. I will tell you more in a future video. Stay tuned.